to continue on in lesson 2.4, and we're still solving inequalities in one variable that require more than one operation to solve them. But yesterday when we did them, the problems that we had yesterday, we undid the addition or subtraction first because that worked best, and then we undid the multiplication or division. Sometimes you're going to have to look at a problem and you're going to have to say, you know what, I think I should undo the division first, and then I'll go about taking care of the subtraction and addition. So the side that x is on, that 5 is being added to x, and that whole thing is being divided by 2. So that at this point, we could not do this. We could not subtract 5 from both sides and say we have x over 2 is greater than whatever 3 minus 5 is. We can't subtract that 5 out of there because that 5 is part of the addition problem that has to be divided by 2. So what we're going to do instead is we're going to say, since it's being divided by 2, I'll multiply both sides of this inequality by that 2. So x plus 5, the expression that has the x in it, is being divided by 2. So we're going to undo that division first. And when we take, remember this one we can put over 1 because make it look like a fraction like the other one is. Because then we have a fraction times a fraction, and when we have that, we can cancel those 2's out. So when we have a fraction times a fraction, and there's something that is upstairs that is we can divide out, and the same thing downstairs, we can just cancel these. So we have x plus 5. Should we reverse the inequality symbol?
No.
Why not?
Because you're not multiplying or dividing by a negative.
Yeah, we did not multiply by a negative, we multiplied by a positive, so we leave our symbol going the direction it was, and 2 times 3 is 6. Okay. Now we can get rid of that 5. What are we going to do?
Subtract it.
Subtract 5 from both sides. So we'll subtract 5, and we will have our solution, x is greater than 1. Here's our solution, algebraically represented. And now we'll also do the graph for it. Open or close circle at that 1. Is 1 included in the solution set?
No.
No, so we have an open circle at 1. What numbers are included?
Anything greater than 1.
Anything greater than 1. So which direction should we shape?
Right.
To the right. All the numbers greater than 1 should satisfy that inequality. Let's just do a quick mental math one and check one. Okay. Pick an odd number for me, because if I add an odd number to another odd number, I get an even number, and we have to divide by 2. So pick an odd number that's in that solution region. 3. Okay. Let's go put it up here, mental math. What's 3 plus 5? 8, right? 3 plus 5. We're putting a 3 in for x right now. 3 plus 5 is 8, and 8 divided by 2 is?
4.
4 is 4 greater than 3.
Yes.
Is that true? Yeah, so looks like we did all right with our shading. Okay, any questions on that one? Okay, no? Okay, what do you think is going to be our first move in this next one then? Jossie?
Multiplying both sides by 3.
Multiplying both sides by 3, because the expression that has the n in it is being divided by 3. So we want to undo that by multiplying by 3. On the left side, we'll put it into a fraction by putting it over 1, so that we can see we have a fraction times a fraction, because what does that allow us to do now? Cancel those 3's, right? Okay, so let's cancel those 3's out. And what do we have now? Cody?
Well, can't the 1's cancel out also?
Ooh, it's tempting to do that, isn't it? But here's what because that 1 is part of an expression that, like the 2n is being subtracted from it, it can't be. We can't cancel those 1's out. We can't make that go away that way. If it was 1 times 2n, then we could, because there'd be multiplication happening. So we're just going to have to bring down the 1 minus 2n. We can't cancel those 1's. And did we multiply by a negative?
Yeah.
No.
multiplied by a positive 3, so we don't want to reverse our symbol. And 7 times 3 is 21. Okay, this is where, when we had a problem like this yesterday, several of you got yourself in trouble here, because you still think that if you see a subtraction sign in the problem, that means you're going to undo that subtraction with addition. But you can't read subtraction backwards. This does not mean the same thing. These do not mean the same thing. 1 minus 2n does not mean the same thing as 2n minus 1. It just does not. And proof of that would be this. What if I said, what is 1 take away, let's say, 4? What's 1 take away 4?
3.
Negative 3, isn't it? 1 take away 4 is negative 3. What if I take 4 and subtract the 1?
3.
That's positive 3. They're not the same thing. 10 take away 5 is not the same as 5 take away 10. So we can't say just because there's subtraction. So instead what we need to do, I think it would be a really good idea, because our inequalities are getting more complicated, change it to add the opposite. Because then we can say, okay, I got an addition problem going on here. I can read addition backwards. 1 is being added. What are we going to do? Subtract 1 from both sides. Yesterday I saw a lot of adding going on in a situation like this. So we're going to subtract 1 from both sides to get that negative 2n alone. Or the other thing that happened is that if you did remember to do the subtraction, you forgot that that subtraction sign in front of the variable part has to actually make that negative. So the subtraction sign really becomes a negative on that 2n. And then what is 21 take away 1? 20, okay. So now what are we going to do? Jazzy? Divide both sides by negative 2. So negative 2n will get divided by negative 2. 20 will get divided by negative 2. And, Jesse?
You switch the symbol around because we divide by negative.
Yeah, we can cancel these negative 2's, and the symbol has to switch because we divided by negative. What's 20 divided by negative 2?
10.
Negative 10. There's our algebraic representation of the solution set. N is less than or equal to negative 10. Any number in that algebraic inequality representation. So what integer neighbor is to the right? What's this integer neighbor?
9. Negative 9.
Negative 9. And this integer neighbor over here is? Negative 11. Okay. What kind of a circle do we want at negative 10? Negative 10 is included, so we want to shade it in. What numbers are smaller than negative 10?
Any letter to the left.
Anything to the left. Negative 11, negative 10 and a half, negative 2 billion. Anything to the left is smaller than negative 10. So again, when we substitute something into that, from that shaded region, it better make that inequality true. So today we're going to look for if this expression that has the variable part in it, if that expression is being divided by a number, we're going to undo that division first, and then we'll have a multi-step one that we're going to still probably have 2 more steps to do. So today there might be 3 steps at work in some of them. Okay, let's go see what else we're going to practice here. Oh, it says sometimes you will need to simplify first before solving. Now, in reality, there are 2 ways to go about solving this one. But I'm not sure that we would understand one of them well enough for you to take that method. So let me see what you suggest we should do. What do you suggest we do, Cody?
Before we start doing inequalities, when we did like problems like this, can't you just multiply negative 4 by 2 and then multiply it by hex?
Okay. So we can do, do you know what that's called, doing that multiplying? What property is that? It's called, anybody know? Distributive property, yeah. So you could do distributive property, which would simplify it first. No, do you have another way to think we could do it?
We would add the opposite to 2 minus x.
That would be a really good thing to do, make it a plus a negative x. Okay, let's start there, because I think that's a really good idea because it'll help us be more successful. So let's change that to add the opposite before we do that distributive property. Okay, there still really is another way to solve this, but I think this is going to be the best way for us to do it. So what we're going to do is we're going to take this -4 that's out front here and we're going to multiply it times both of those. So what's -4 times 2? I need to hear from a voice to make sure some of these people still have their vocal cords. Abby? -8. So -4 times 2 is -8 plus -4 times -x. Devontae, what's that?
4x.
4x. A negative times a negative is a positive, so it becomes 4x. Now, do we switch the symbol around?
No.
We multiply by a negative number.
Oh, but
we
did it
didn't
in
multiply by both
parentheses.
sides.
Oh, yeah, but we didn't do it to both sides. We were getting rid of the parentheses. We were simplifying. We were not solving. It's when we're solving that if we multiply or divide by a negative. In other words, if we do it to both sides. Are we going to do it to both sides? No, we're just getting rid of the parentheses on the left side, so we do not switch the symbol around right now because of that. Okay, and it would be tempting to because we did multiply by a negative. But we were simplifying, not solving. Okay, go ahead and finish solving this, because what would your next move be?
Add -8.
No, add the opposite. Whenever a negative number is being added to, you have to subtract that, which is the same as adding the opposite. So just add the opposite of -8. What's the opposite of -8?
8.
8. Add 8 to both sides. Finish it up, wrap it, and then see if you agree with mine. Me? Yeah? Okay. Then I'm gonna let my answer be. If you agree with me, I trust you guys that we are right. Okay, anybody have any questions? So in your homework, I'm not really sure, I haven't really looked at that to see if you'll have some that were like yesterday, or if these will all be kind of like what they were, what we just did in the notes today, and then when we come back, we'll combine a bunch of stuff.